Hello, everyone, and very warm welcome to today's SAP Community Call on the topic of SAP HANA Cloud, an overview of Data Lake. I'm thrilled to be joined by our speaker, Jason Hinsperger, today. He's part of the SAP HANA Product Management Organization and responsible for SAP HANA Cloud Data Lake. We already had a session yesterday with our colleague, Thomas Hammer, and we would like to know, I'm already starting a poll, who joined the session yesterday. That will be helpful for Jason to know whether you already have a little bit of a background of SAP HANA Cloud, the overview that we had yesterday, and how deep he has to go into detail of the Data Lake version today. I'm Lena Stoder, by the way, from the SAP Community and Influencers team, and I'm your technical host for the session. We already used the chat a little and shared where we're from. That's really what the chat is for. And for questions, because we have dedicated time towards the end of the session to answer all your questions, please use the Q&A. It's at the bottom of your screen here in Zoom to ask all your questions. There we can also have the upvotes. So Jason will know at the end which ones are most pressing topics to answer them first. Okay. With that being said, Jason, you see in the poll already, most of our attendees have not been at the session yesterday. And I'll hand over to you, Jason. Thank you.
Okay, thanks, Lena. So hi, everyone. My name is Jason Hinsperger. As Lena said, I'm a member of the HANA Product Management team. And today, I'm going to talk to you about the data lake. So it's kind of interesting to see that most of you were not at the session yesterday with Thomas. So what I'm going to do is spend a little bit of time talking about HANA Cloud itself, just at the start, so we have a good base for the discussion. And then we'll drill into the HANA Cloud data lake, the overall architecture, the main use cases we're looking at, and then we should have some time to show you a demo of how all of this works together. So it's a great technology, and I'm looking forward to talking to you about it. So obviously, starting at the high level, why is SAP doing this? We hear this all the time. Data is the new oil. Lots of data everywhere, different types, increasing volumes, etc. Of course, the move to the cloud is a big thing right now. So lots of people looking to divest on-premise investments in favor of cloud to manage infrastructure, to facilitate easier scale up, scale down, those kinds of things. But at the end of the day, you still need to deliver on your business requirements. So whatever types of intelligence you need to get out of your data are still there. So you need to do that. You need to do that quickly, and you need to do that cheaply, hopefully cheaper than you were able to do it on premise. Excuse me. So some of the things that we target ourselves is, faster provisioning. So no longer having to spec out hardware, order hardware, get it in, set it up, install all the required basic OS requirements, and then add on your database installation itself and manage all that stuff. We want to ensure maximum utilization of the resources that you are deploying in the cloud. So rather than having a machine on premise sitting idle 8 or 10 hours a day while no one's working, maybe in the cloud you can stop a service and not pay for the service while you're not using the compute. So being able to offer that consumption-based pricing is a big thing. Obviously, elastic scale ties into both of those things. So the ability to increase the amount of resources you have available to you based on the demand of your business is important in terms of ensuring consistency in delivery and ensuring control over your costs. And finally, obviously, all of those aspects are fully managed. So having SAP take care of all of the care and feeding for all of the infrastructure behind your data and your business so that you can focus on the data, generating value from it. So in terms of data lakes themselves, just at as a bit of a background, so what is a data lake? So here's sort of the definition that I work with. That data lake is a collection of data of all types, structured, semi-structured, and unstructured. And it's collected into a lake, so a common repository. So that gives you one place to look for data, one place to manage access, one place to find it. So some basic features of your data lake, you want to be able to get that data in there quickly. You don't want to pay a lot for it because oftentimes the data itself has an unknown value or a low value to your business, but you need to have it around. You want it to be able to scale unlimited to unlimited capacity, so you don't want to hit some sort of limit in the middle of adding data to your data lake. Obviously, you need APIs for access, and obviously you need to secure and protect that data from external sources to extent. So in some cases it doesn't matter, in other cases it's highly critical. So this is what you would see today with like your S3 kind of object storage that you see from the hyperscalers that is being equated to the data lake. And it is a natural fit with the cloud infrastructure, right? Being able to do all the things that I talked about. The problem is okay, you have all this data together. How do you generate value from it, and how do you make sure that it stays organized or self-organizes, and your business users can actually make heads or tails out of it? Your data scientists can find what they need, because the more data you have, the more difficult that becomes, and you risk this this term called data swamp, where it's basically a mess of data. You don't know the quality, you don't know where things are, that sort of thing. So now we see sort of the evolution of the data lake into this more specific environment where you still have all those requirements we talked about of any type of data coming in, but you are operating on that data to ensure that it has value when you're ready and is available when you're ready to use it. So a typical pattern that we see with lots of customers and lots of use cases that I've investigated is, you have this landing zone for the data. So this is like your raw data, just getting it into your environment. You don't necessarily know a lot about it, or maybe you do, but it's kind of irrelevant. So you've got it in. The next thing you want to do is automate the transformation, conversion, filtering, so your data cleaning, your data quality type operations on that landing zone data. And so as you process that landing zone data, it moves into your staging zone. So once it's in your staging zone, this is the point at which you have all the metadata about the data. And so that is what makes it actually valuable to your business. So at this point, the data has been cleaned, it's consistent. You've got a catalog of what is where and all that sort of thing. And then on top of that, you then have your data exploration type of activities. So this is your database access, your REST API for data science types activities, generating indexes to facilitate fast searching over terabytes or petabytes of data, all that kind of thing. And then at the other end are the processes that you have from your business. So your real-time analytics, dashboards, machine learning, applications, obviously, building on top of that. So this is where things are evolving to in the data lake. And this is what we're bringing to the table with the HANA Cloud Data Lake. So just by way of overview of HANA Cloud itself, it is designed to be the gateway to data inside of your enterprise. And HANA Cloud consists of a collection of services for managing and federating access to data, regardless of where it lives within or outside your enterprise. So obviously the cornerstone of the HANA Cloud is the HANA database itself, which is a multi-model database offering you the ability to store and manage data for HTAP applications, so hybrid, transactional, and analytical, different types of data, like spatial, graph, JSON, all those kinds of things can be stored and queried efficiently inside of the HANA database. And so yeah. Okay, in addition to that, we have the data lake, which is where we're going to focus today, which is designed as an OLAP, high volume, low TCO data store for HANA Cloud. So designed to support storing any type of data, providing high performance query access, SQL query access to any relational data, and REST API access to relational and non-relational data alike to external applications. And then finally, we have ASE, which was released in Q1 of this year as a component of HANA Cloud, designed to provide high performance OLTP access with replication inbuilt. If we take a look at HANA Cloud in terms of the data pyramid, it kind of makes sense where we see the data lake fitting in. So at the top, obviously we have our in-memory HANA database. This is where we get the highest performance. This is where we would have the highest performance, but the highest cost. And so from a TCO perspective, you only want to store the data there that is high value to your business. So either requires real-time access, is critical to business operations. So as we move down the pyramid, we have the cost of managing and storing data going down, but the performance for accessing that data goes down as well. Whoops. So NSE as the attached disk-based storage for HANADB provides disk-based storage, but obviously has a lower performance threshold. Moving down to the data lake, now we're moving into the sort of 50 terabyte plus range of data that's not being changed very much. Again, much lower cost to store and manage that data, but at the cost of performance. Excuse me. And then finally at the bottom, we have that raw data store, which could be your hyperscaler object storage, could be HDFS or things like that. So I think I'll skip this slide and we'll skip right into the data lake technology itself. So now I'm going to talk about what are the pieces that make up the HANA Cloud Data Lake. So the key sort of central piece of data lake of the HANA Cloud Data Lake is the SAP IQ technology. So the SAP IQ technology is a relational column-based data store. Came from the Sybase acquisition many years ago. And it provides a mature, high-performance, petabyte scale SQL engine for data in the data lake. And so what that means is, and maintain SQL query access to your data even after you've aged it out or moved it out of your HANA database. And so you can make it available to the same processes via extensions in your application, or you can make it available to other applications, like doing data science and things like that, where you want access to much larger volumes of data. So the data lake IQ component itself scales independently from the HANA database. So you can scale compute and storage independent of the HANA database. And we'll see that a bit when I show you how the provisioning works. It's designed to provide high-speed ingestion. So basically, the sort of rule of thumb that we go with is you can ingest about 1 terabyte of data per core per day into the HANA Data Lake IQ store. So and we support basically several nodes in an instance because the Data Lake IQ is based on a clustered called IQ multiplex. And what that is a multi-node multi-node system running within Kubernetes that provides all of your database service access. So what that means is you can have several nodes with multiple CPUs per node to provide the compute power for your instance. As I said, everything's accessible through SQL, and there are common interfaces for all the major interfaces. And there are two ways to basically access the data lake. You can access it directly, or you can access it through a managed HANA instance. And so there's some real benefits in both cases. If you're coming from the HANA background and you want to extend out to the data lake, using a managed instance is very useful because you can manage all permissions and all access to the data lake through your HANA connections. And so it provides a much a uniform interface to the data lake. On the other hand, if you're coming from an on-premise SAP IQ background, having a direct connection to the data lake it is obviously much more useful in terms of looking at migration and things of that nature. I think that's good for that. So the other component, major component of the HANA Cloud Data Lake, obviously, so I've been talking to this point about relational data and how we can store large volumes of it in the data lake, but that is only one piece of the puzzle. The data lake also needs to support semi-structured and unstructured data, and that is where the data lake files component comes in. So data lake files is a managed object store that is part of the data lake that provides you efficient storage for structured, semi-structured, and unstructured data stored as files. It's always provisioned as part of your data lake service and supports sort of a standard REST API based on Web HDFS and uses certificates to manage authorization and access to the files themselves. So data lake files has a few really good uses. One is as a landing zone for data from external sources. So if you think back to the initial sort of evolution of the data lake, we want that landing zone and the staging zone. So we could have a landing zone in data lake files where we have our files land. We can do processing over those files using things like data intelligence or data services to cleanse and transform that data, and then load it into our data lake IQ, load it into our HANA DB, depending on the value that we determine for that data. And of course, having the data in files is useful to lots of other development methodologies. So if you want to, for example, access the data from something like Spark, you can access it as a file. Obviously, you could use Spark SQL as well, but accessing it as a file is a common usage pattern. And finally, we only charge for the data that you store in the files. So we have this really cool data lake files service. We have data lake IQ, and at first blush, you might think that they're kind of unrelated, but the fact is they all come together to provide this unified view of the data lake. And so one of the ways that we can enable that unified view is using the SQL on Files feature. And so what this enables you to do is to provide SQL access directly to files in the data lake. So if you've got a landing zone where you're ingesting large volumes of relational format data from a Kafka stream or from Weblog or something like that, you can do basic analysis of these data sets without having to load them into data lake IQ. So there's no preparation or format or cleansing required. So you don't have to wait to get the data into data lake IQ before you can access it via SQL queries. So this is an even lower TCO way to do basic data analysis for large volumes of data. And we'll see why I say large volumes when I get to the demo in a couple of minutes. Obviously, this is a fully integrated part of the data lake, and it's accessed through the data lake IQ component. So you can use, again, in a managed way through HANA to the data lake or through the direct connection to the data lake. There are some specific formats that are supported for the file. So Parquet, Orc, and CSV are sort of common relational formats that we see. And then it supports the full set of SQL syntax to do analysis over those files. The nice thing about the SQL file service is, again, it is a built-in piece of the data lake. And so, you only are charged for it when you use it. So, and when you use SQL Files, it's actually a serverless component of the data lake. And what that means is when you execute a query over SQL Files, Data Lake IQ actually will spin up the SQL Files engine. The SQL Files engine analyzes the query and creates parallel threads for executing the query plan that it generates from the SQL. And then when that finishes, the result set is returned and all that compute is spun back down. So you're only charged while the query is running. Okay, so again, we'll show this in a bit of a demo, but I just wanted to show, it's kind of a neat feature. You might, if Amazon Athena or BigQuery, it's kind of a similar kind of a thing where you can access your files directly from SQL. Basically, you add them as data sources to a files table, and then you access the table as a normal table in a database. So I think at this point, I'm going to slip into the demo piece, and then we'll come back and we'll talk about a little bit more about specific use cases. So let me get my correct browser window open here. So first thing, so what you should be seeing on your screen is the HANA Cloud Central tool. So your entry point into HANA Cloud is through the BTP cockpit, so Business Technology Platform cockpit. When you set up entitlement for your account for HANA Cloud, you have access to a HANA Cloud entry point here. And here's where you'll see, you see here all the HANA Cloud instances that I have running. And then there's this button for Manage SAP HANA Cloud. When you click that, it opens up the instances tab that you see now. So here is a list of all the instances I have running in this sub account. Let me do a quick refresh because I think something was restarting for me. And we can see it. So what we can do is we can create, if we want to create a HANA database, and we give our instance a name. And password, which doesn't match. Right. There we go. So we can configure our HANA database instance with what we want, memory, CPUs, etc. We can set up our allow list for IP addresses, enable whether or not we want to enable connections from on-prem sources using the cloud connector. Do we want to use the JSON document store, script server, etc. And then we can then we go to this, do you want to create a data lake? And if you choose to create a managed data lake as part of your HANA database provisioning process, again, you give it a name. And then there are some configuration options for your data lake. So you choose your compute power for CPU for your coordinator. So the coordinator is kind of the cluster manager for data lake, and typically it doesn't need a lot of compute, so 2 vCPUs is fine for starters. And then the number of worker nodes. So these are the nodes that are doing query processing, handling connections, and all that kind of thing. So We recommend a minimum of 16 vCPUs, but if you're just sort of kicking the tires, you can crank that all the way down to 2. So here we have a minimum instance size of 4. Similarly with storage, you can have a minimum of 1 terabyte of storage. And then same thing, you can set the allow list. You can copy, if you have a specific IP list, you can just copy the same one from HANA database. And then when you're finished, you would hit create instance. And that takes about 15 minutes at the moment. So I'm not going to let that run. And what you end up with at the end is, if you see this QRC2, these 2 instances right here, this is what you would end up with. So here is my HANA database instance, and here is my HANA Data Lake instance. And you can see in the UI that they are tightly tied together. And so that what that means is this data lake instance is a managed piece of this HANA database. You can see I have another one up here from my Q1 demos as well. So the other way you can create a data lake instance is just as a standalone component. I won't run through the whole process. It's basically the same wizard and options that we just saw from the HANA managed side. And in the end, when you create the instance, then you see something like this running. So you see an individual piece, an individual data lake instance running. And so this is called what we call a standalone data lake. So the standalone data lake is running here. So a couple things to note there. When you're accessing the data lake, you are still able to connect directly to a managed data lake if you wish. So from a functional perspective, you still have, regardless of whether you create a managed or a standalone data lake. But as I said earlier, the benefit for a managed data lake, if you're coming from the HANA perspective, is that common management through HANA that you can leverage, and then makes it a little bit easier to get into things. So so one of the nice things about HANA Cloud is we are, the vision is to have a common set of tools and accessors. So the common access tool for HANA DB is Database Explorer, and Database Explorer fully supports the data lake. So here at the top, this is my data lake instance, and you can see sort of the various catalog objects that I have available. And then you can also see my HANA connection, which is a regular HANA DB connection. So in terms of the interaction between, or how do you create schema in the data lake? How do you create tables, or how do you add files and all that sort of thing? So this is kind of what we're going to cover now. So in the managed scenario, which is what you're seeing on the SQL console right now, this is a connection to the HANA database. And what I want to do is create a table in my data lake. So there's 2 ways I can do that. So the first way is via this remote execute procedure. And what this procedure does is it actually sends whatever text you put in here to the data lake to be executed directly. So you might want to use this if there is specific IQ syntax that is not supported by HANA, and you want to create a table in IQ, or you want to maybe create a stored procedure or a view, or execute some sort of batch. You can use remote execute to execute any SQL that is supported by the data lake. The other way that you can create a table, and I should say, when you create a table this way, there's a virtual table automatically created on the HANA side that enables access to the data lake table. So in this case, if I create this table HDLT2 on the data lake, a virtual table called HDL, here you can see I did an earlier example with HDLT1. this table appears on the HANA side. So if I want to access the data lake, I'm just selecting from HDLT1 as if it were a regular table. The other and probably preferred method for creating data lake tables is to use the HANA create virtual table statement. So here's an example of that. I'm creating this vpets table, and I'm saying, I'm creating this vpets virtual table, and I'm saying I'm creating it at my data lake. So this is the remote source that gets automatically created. Unfortunately, it doesn't have the most user-friendly name in the world, but it is what it is. So when you provision the managed data lake, one of the things we do under the covers is create a remote source automatically that points to the data lake. So you create this virtual table, you want to say I'm creating it in the data lake, and the data lake table name can be the same or it can be different. And this extra clause with remote means that we will create the table on the data lake side, to create the base table in the data lake and the virtual table in HANA at the same time. So if I execute that and then refresh my table list, I should see my new vpets table here. And once I have that table, when I select from it, it's actually going out to the data lake and executing a select. So there's no data right there in there right now. But what I can do is execute, again, use this remote execute procedure to load data. So I can use a standard insert statement to insert data into the virtual table, and that will insert the data directly into the data lake for me. But the sort of the best practice for high volume loading of data is to use files. And so we use a remote execute statement to execute a load table against the data lake table. And the load table is loading from this cats.csv file. And it does the bulk load. I mean, it's not loading a lot of rows, so it is really fast. Now when we select, we see I've got a couple of pets loaded into my pets table. So a couple things of note here. Again, this load table is specific syntax to IQ, so it's not executing through HANA. HANA sends that statement to IQ, and IQ's executing it, or the data lake IQ is executing it natively. So there's no overhead in terms of transferring the data through the HANA connection. The data is coming directly into the data lake. And the other thing is we're leveraging our HDL files feature here. So what I did beforehand was I uploaded cats.csv into my HDL files. So it was available there, and then I'm just loading from that. So a simple way to get data into HDL, into Data Lake IQ for analysis from Data Lake files. You can also load directly from object storage like Amazon S3 and Azure Blob Store in the same method. So there's you would use, your S3 path here, and you would provide your access keys as part of the load table statement, and that would load the data from an external S3 source if you wanted to do it that way. So if we take a look a little bit further into the HDL files component of the data lake, we can see there is an HDL files CLI, which lets me use a REST API. It's basically under the covers a REST API to access the data lake files component. So I just ran the CLI and just did an ls on my data lake files, and it shows I've got a file and a directory. If I look in the home directory, files, sort of standard file system stuff, and we can see the files that I've got in there. So I've got two files, cats and dogs. So if I want to use those files or load them into my data lake using the direct connection now. So here whereas in the first case, I was using the HANA managed connection. In this case, now I'm connected directly. So again, it's nice that we have common tooling for accessing the data lake. We don't have to switch to a new tool or learn a new tool. We can just, open a SQL console against the data lake itself. So here I'm going to create a table in the data lake. I'm going to load the data from HDL files. So I'm just specifying the 2 files that I want to load. They'll get loaded in, and then I can select them. And then, so now that data is available for querying any kind of query. So the other nice thing is I can also unload data into files. If I have a look here now, I've unloaded this cats file. Sorry, I've unloaded the content of my table into this file in the data lake files. And if I look at the content of it, sorry, if I look at the content of it, it shows me what I've dumped out. So now this data, now I have this file available for other use cases if I need it, or if I want to transfer it to something else. So currently the HANA DB doesn't have direct access to HDL files, but that will be coming fairly shortly, I'm sure. So you'll be also able to more easily transfer data between HANA DB and data lake using this intermediate files mechanism as well. So if you're moving a large volume of data, again, using like insert select is not as performant as an export and import kind of activity. So the final thing I wanted to show is this whole SQL files thing that I talked about. So this is the ability to execute SQL directly against files in the data lake. And so again, this is a direct connection to our data lake, but I could execute these same statements through the managed connection too if I wanted to. We're going to create a SQL files table. So we use this thing called the files service. We create a table in our files service, and then we create a table in HDLIQ for referencing the file service table. And then what we can do is add data sources. So data sources are basically files, individual or sets of files for the table to refer to. So when I execute a query, all the data source files attached to the table are used to satisfy it. So I'm going to create a couple of data sources for my SQL files table. So here I'm just using, that cats and dogs CSV file that I created earlier. Again, the data source syntax itself is very flexible. So here's an example where I could have just supplied the directory name and it would automatically grab all files in the directory. You can use wildcards, all sorts of different options there. And then when I'm ready and I want to do some analysis, I can run, again, any kind of query syntax against that table. So the interesting thing about SQL files is, or sorry, not the interesting thing, but this goes back to when I mentioned earlier, querying large volumes of data. So you'll notice that it takes a little while to retrieve the data, even though there's only 4 rows. So this is an artifact of the serverless nature of SQL files. So what's happening in the background is we're spinning up the compute to execute the query and then spinning it down at the end. So there's always that spin up overhead for every query. So if you're only analyzing small amounts of data, it's far more efficient to actually load the data into Data Lake IQ and then query it. But if you're querying, hundreds of gigabytes or terabytes of data in files, then using SQL files becomes a much more attractive and efficient option. So that's the end of that. Just do my little cleanup here. That's fine. Okay, and then I wanted to show you sort of some of the flexibility that you can also get with SQL files in terms of generating more information. So you might have noticed that I had a dogs file and a cats file, but my actual table definition just had like a name, age, and cost. So I have a bunch of pets with names and ages and costs, but I don't know if they're cats or they're dogs. So, but if I look at the file names, I can see that they are cats and dogs. So what I can do as part of my data source definition, I can say that there are things like the directory name or the file name that are key components that provide context to the data. And so what I'm doing here is I'm creating a data source called animals, which is using all of the files, so the cats and dog file, but I'm pulling the pet type from, this is telling me to pull it from this will pull it from basically the file name, and then the name, age, and cost from the file itself. So now if I rerun my query, it's going to again spin up that compute. So we're incurring that overhead, and then we'll see the results. A second here. There we go. And now we can see, so I've got the same results as before in terms of name, age, and cost, but now I've got a pet type. So I can say, I know that these are cats and these are dogs. And so you can get fancier and instead of cats.csv, you can make this say cats or whatever, but you get the idea. Okay, so that's sort of a run through whirlwind tour of the data lake, how you use it, how you can access it, and what you can get out of it. And so now I'm just going to spend a couple minutes talking about some use cases, and then we'll get into we'll see if there's any Q&A that we want to talk about. So obviously we kind of talked over this generic use case pattern where data is coming in, we want to process it and then make it available for querying. So this is that basic use case for data lakes that we're seeing moving into the future, where you've got your landing zone, staging zone, and then data exploration. So obviously we've got our landing zone, which is data lake files. We've got then our processing on the data, which can either be a direct load into Data Lake IQ, or it could go through, like I said earlier, a data intelligence pipeline to do some cleansing activities on it. And then once it's in Data Lake IQ, it's available for advanced sort of OLAP analysis in the data exploration phase. And of course, we can also do data exploration against the files directly if we sort of need to do, if there is significant cleansing involved and we want immediate access to the raw data, we can do it that way. Or if there's large volumes of raw data that have unknown value, we can look at them that way. And once we have the data available in that data exploration phase, it's then sort of fully available through your HANA connection, through a direct connection. So you can create, use SAC to build dashboards, you can run machine learning models against it, all that sort of thing. So the second sort of use case I wanted to talk about is data tiering. So data aging and data movement. When we talked about the data pyramid, we've seen the trade-offs between each layer in the pyramid depending on your requirements. And you want to be able to move the data around. So today, I talked about using HDL files as that layer for enabling movement of data between the various tiers in the data pyramid. And you see on the left-hand side, sort of a general indication of the expectations on the data when we move it to the different layers in the pyramid. So by the time the data gets to the data lake, the expectation is that the data doesn't really change very much, but you still want to have the ability to do analytics on it. And so moving that data today is basically a manual process. So you need to manage, moving the data using SQL or using external processing. But we are working on a data movement service that would be a little bit similar to what you might have if you're familiar with Data Lifecycle Manager in the HANA on-prem world. So that will allow you to define a rule to say, for example, any data older than 3 months, move it to the data lake. Or vice versa, you could create a rule that says at year end, I want to move aggregate data from the last 4 quarters from the data lake up into my HANA in-memory so that I can facilitate dashboarding and that kind of thing. So that's in development. We're hoping to have that out in the near future. Sort of big use case we see is we have lots and lots of on-premise SAP IQ customers who are looking for a solution in the cloud, and I mean this is that solution. So having a standalone data lake provides managed IQ service in the cloud, which is fully compatible with the SAP IQ on-premise database. In fact, you can use the same exact interfaces that you use on-premise, so JDBC, ODBC, Python, Perl, whatever you're using to connect to your IQ database. You update the connect string, and you can talk to HANA Cloud Data Lake IQ. And so we make it super simple for applications to migrate to using Data Lake IQ. Obviously, the big sticking point there is movement of data. If our on-premise IQ databases are typically multi-terabyte, and so we have some methodologies and some I think it's called a migration factory that facilitates and helps with IQ on-premise migrations to the cloud. If that's something that you want to learn more about. Okay, so here we are to the summary. So hopefully I've gotten across that we've got a modern data architecture in HANA Cloud that enables storage of data from any source. We've got an integrated set of tooling and administration capabilities that make it easy for you to manage the data regardless of whether it's in HANA-DB or Data Lake. It's scalable and elastic, so you can scale up, scale down as you need. Advanced full SQL access. IQ is an incredibly mature columnar database product, so it's very robust in terms of what it can do and what it can support. And then we talked through the use cases. Excuse me. So some additional information. Obviously, the help is a great place to get details on specific features. And if you go to the SAP Tutorial Navigator in the SAP community, there are a bunch of tutorials that are specific for. So there's a bunch of HANA Cloud tutorials that are specific to the data lake piece. So with that, I come to the end of my presentation. Thank you very much for your time. And I'm just going to switch now. Please feel free to post any questions you have in the Q&A. And I'll have a quick look through here. Yeah, so just a comment. How does S4 HANA fit into this picture? It looks like Jorg is going to answer that, so I'll let Jorg answer that. If you want, Jorg, you could answer that live, or you could just type the answer. I'll leave that up to you.
Sorry, I was too late. Already done.
Okay, no problem. I think for natural language processing or huge text data, this is a great option for customers. Yeah, so there is obviously you can store this data in data lake files, and you can then access it from external sources. We don't yet have built-in compute for things like natural language processing, but with the BTP and the sort of the rise of Kima inside of the BTP, bringing compute into your environment, external compute into your environment becomes a much more attractive option. How do the rules for moving data from HANA to Data Lake look? Any possible links? So we're not quite ready to share that level of detail. What it is a it will be a REST-based API for generating the data rules. And you can think of a data rule in its simplest form as a where clause against a table. It's a little bit more complex than that, but basically you're defining a where clause to define the set of data you want to move, and you're picking your source and your destination, and then scheduling when you want to do that. Was there any performance comparison of Sybase IQ and other disk-based databases? So Sybase IQ published lots of TPCH benchmarks in the past. I don't think since Sybase joined SAP, there's been any published benchmarks. But certainly, I have no issue with saying Sybase IQ is probably one of the highest performing data warehouses in the market, data warehouse databases in the market, especially when it comes to data ingest. We can bring data into SAP IQ faster than anybody. How different is SAP HANA Data Lake from SAP Data Hub? So Data Hub, or Data Intelligence as I was referring to it, is more of an orchestration and processing for data. It does not do data storage. So Data Hub would pull data out of SAP HANA Data Lake or load data into SAP HANA Data Lake. Now, if you're familiar with Data Hub actually comes with a component called a data lake, and we're actually in the middle of replacing the Data Hub data lake with the HANA Data Lake. So in the very near future, you will, when you want to use a data lake from within Data Hub, you'll be using the HANA Data Lake, and so it will be a common component across the data management services. How are we doing for time? Okay, we got time. So how does this concept fit in for DWC? Say I have to access data lake from a DWC space. Would it be through OpenSQL access for HC container? Yeah. So in DWC, there's a couple things. So DWC actually includes so the DWC HANA Cloud instance also includes data lake. So you have data lake as part of DWC in your various DWC t-shirt sizes. So you have sort of the native access. But if you have an external data lake from DWC, yeah, you can use an OpenSQL schema to access it that way. In the near future, DWC will also be supporting direct connections to the data lake as well. When will the data movement service be available? So we don't have a public published roadmap for that item at this time. All I can say is it's been in active development for quite some time. So, as a product manager, I'm hoping that it would be out yesterday, but we have to make sure it's finished, and we have to make sure it's high quality, and we have to make sure it fits in with all of the HANA Cloud infrastructure that we have in place. So, yeah. In what scenario customers will choose the data lake option along with the HANA database? So I assume this is referring to the managed data lake option. So this is, as I said, so if you are a HANA database user and you're building HANA applications, or you have a HANA-based application, and or you have several HANA-based applications, and you want to either, your HANA instance is getting very large, and you want to move some data out to control TCO, or you've got several HANA instances and you want to provide an aggregation layer where you're bringing data from several instances together to provide an overall query, an overall set of data that you can analyze for data science or for dashboarding or business purposes. you would use the data lake as an option there. So data lake can help you lower TCO for your HANA instance, and it can provide a data store, an aggregate data store for multiple HANA instances. And again, as I said, having it as a managed component allows you to control things like permissions. So all your users, permissions, table access can be managed through your HANA database user management. If you're connecting directly to the data lake, then you are managing users directly inside the data lake. And so you can get into having multiple layers of security and different security depending on whether it's managed or direct access. So managed access in that sense is somewhat easier. And the final reason you would want to go through a managed layer is if you're using a tool like SAC live connections only work against HANA Calc views. And so you would need to create Calc views in HANA against your data lake tables to make them visible through SAC live connections. And now you could use the SAC ingest functionality to pull data from the data lake into SAC to analyze it, but given the target environment for the data lake is hundreds of terabytes of data, you really don't want to try and pull that into SAC. So that would be the sort of the third place where having a managed data lake makes sense. Okay, I think that's the end of our questions, and that is the end of our hour as well. So I will turn it back to you, Lena. Thanks very much, everyone, for your time.
Thank you, Jason, and a very good job on the timing. Well done. We have all our 15 questions answered, and I just shared in the chat that if there's more questions coming up, you're of course free to also share or ask your questions in the SAP community. Thank you, Jason, for your time. Thank you, everyone, for attending our session today, and have a great rest of your day. Good night, or see you soon.
Thanks all. Bye.